Today we are going to be factoring a four-term polynomial. We're going to do it using a method called grouping the terms. And then we will end up seeing that we have a common binomial as a factor. So let's take a look at the first problem here. We got our four-term polynomial, and the way we're going to do it is always look at the order. Now there's two parts to this lesson. The first part will have everything in order to start with. It'll all be in descending order. So I've talked about this term descending order a few times. Right from the beginning when we dealt with polynomials and just adding them together, I talked about descending order. And descending order is important, I said, because when we get into factoring, we're going to want to use that. Well, here's where we need to use it. So we're going to take a look at the terms, and that's all in descending order to start with. So these four examples are already in descending order, and we're ready to factor by grouping. But the next part, they're not going to be, and so we'll have to reorder it first and then factor by grouping. So first thing again is we're going to get in the habit of always looking to see if it's in descending order, and then looking at all the factors of the terms. We have four terms here. And are there any common factors? No, we don't see any common factors. So we're not going to be able to pull anything out. We always look for that first, common factors between the terms and descending order. So from there, we're going to go ahead and group the first two terms and the last two terms. And when we do this, we're going to look for the common factors in these two parts, in these separate binomials that we just made. And so we'll take a look at the 6x to the third, the 4x to the second. What's in common between these? Well, I see a 2 goes into each of those terms because they're even coefficients. And I can take out an x squared. So x squared is taken out, and the common factor of 2. Over here, what's in common between these? Well, I don't see any number, but we have to have a number. And so if we don't see any number, use 1 as the number. And so now what we're going to do from this point is take that common factor, 2x squared, and we're going to put it on the outside of a parenthesis, 2x squared, and then we're going to do some reducing. So let's go ahead and do that. See, this 2 will cancel out this 6 and make it a 3. These two x's will cancel out 2 of the x's here, leaving us just with 1x left over. So let's go ahead and rewrite what we had there. We have 3x. And so over here, do the same thing. This 2 will cancel out this 4, leaving us with 2 left on top. So plus 2, and all the x's should cancel. And that's what happens here. And so we are left with 3x plus 2. Well, let's go ahead and rewrite what we've got on the other part. We see we factored out a 1, so it's going to be a positive 1 that we took out. And what's left over? Well, we have that same factor. See, it's 3x plus 2. So now it becomes a problem like we dealt with yesterday, where we took out the common factor that was a binomial. See, now we've factored out those common factors, and we can factor one more time. So we can take these two terms, remember there's only two terms here, and take out that common binomial, the 3x plus 2. So we'll do that on both the parts, and now we've got another set to do. So we take out that common factor of 3x plus 2, which I need to put in parentheses. So 3x plus 2, that's one number there, that's why it's in parentheses, and it's being multiplied by whatever's left over. You see, these 3x plus 2's cancel out, so what's left over? It's the 2x squared. What's left over here? Well, these cancel out. Well, it's the positive 1. And there's our answer. 3x plus 2 times by another binomial of 2x squared plus 1. And again, the whole reason for doing this, we learn later on. We'll solve quadratics later on, and we can solve any kind of polynomial. And this is one way to solve, is by factoring. And so once we factor, we'll notice that we can end up solving for these variable x's. And we'll learn that in a later chapter. Well, let's take a look at this one. Again, we're trying to factor it. So we're taking a look at the terms, see if they're in descending order. Look for common factors. Let's write that down too. Look for common factors. And so I don't see any common factors between these terms. And you see, this almost has a factor of 2 in the last 3 terms here, but this doesn't have it. Almost have x's as a common factor, but 8 doesn't have it. And so if we don't see any, then we go ahead and draw our parentheses around the first 2 terms and last 2 terms. And we take out the common factor. So let's take a look at these 2 terms. We have x squared as the common factor. Over here, we have a different factor other than 1 this time. We have a 2 goes into each of these terms. And so once we've done that, we take that common factor and put it on the outside of a parenthesis and then do some reducing. So let's go ahead and do that reducing now. These x's will cancel out 2 of the x's on top, leaving us with 1x. So we have that x. These x squareds will cancel out, leaving us just with a 4, so positive 4. Then we do the same thing with the next one. We take that positive 2, put it on the outside of a parenthesis, and do the reducing. See what's left over. So we have this 2 will cancel out this 2, leaving us with an x. This 2 goes into 8 4 times, so we have a plus 4. And you'll see that we have a common factor. See, we've got 2 terms here. We've got an x squared times by a binomial of x plus 4. 2 times by the binomial of x plus 4. Well, what's the common factor? The binomial, x plus 4. That's what's in common. So that's what goes inside the parentheses. And we go ahead and rewrite our problem here. We've got an x plus 4 that we're taking out. So put that in parentheses. That's being multiplied by whatever's left over when we do the reducing. And so we go ahead and take out the common factor of x plus 4. What's left over? It's the x squared. So that goes inside. Take out the x plus 4. What's left over? It's the positive 2. That's what goes inside. So there's our answer. Alright, so again, the reason why we do this is later on we'll be able to solve for x, but we can't solve until we get that equal sign. So all we're working on here is just being able to get comfortable with this concept of factoring so that later on we can solve for unknowns. So let's take a look at another one here. Again, the whole idea is to make sure it's in descending order and then look for common factors. So descending order. Yes, we have the highest exponent down to the constant. Common factors? No. All of them are even except for 5, so can't take out a 2. All of them have a's except for the last term. So what we have to do is draw parentheses around each of the 2 terms. We're grouping the first 2 terms and the last 2 terms. And then we're looking for common factors. So let's take a look at this first set. We've got a 2 that goes into each of those 2 coefficients of 10 and 4. And we've got 2 a's, a squared and a squared. Over here, no numbers go into 5 and 2, but we always have that common factor of 1. So we go ahead and take out that common factor of 2a squared, and we go ahead and do some reducing. So let's do that. We take out the 2, goes into 10 5 times, so we put the 5 in there. Take out these 2 a's, we'll cancel out 2 of the a's here, leaving us with 1a left over. Over here, this 2 will cancel out that 4, leaving us with 2 on top, so plus 2. And then how many a's? Well, these 2 a's cancel out those 2 a's, so no more a's left over. Well, we do the same thing on the next problem. We take out that common factor, positive 1, put it on the outside of a parenthesis, and then do the reducing. Let's see what's left over. Well, when we divide by 1, nothing changes, so we're just left with what we had in there originally, 5a plus 2. And again, the whole reason for doing this is so that we can see what that common factor is. And the common factor between these 2 terms is a 5a plus 2. So that's what we're going to take out. And so once we take that 5a plus 2, let's see what's left over. So we're going to rewrite that 5a plus 2, put it in parentheses because that represents one number, and then over here we'll take out that 5a plus 2 from each of these 2 terms that I just had underlined and see what's left over. Here we have just a 2a squared. Over here we have a positive 1, and that's it. It's as far as we take it right there, and that's the answer. Well, one more problem to practice, and then we'll move on to another little more difficult concept. And here again, we always look for descending order and look for common factors. and we haven't seen any. They've all been in descending order. So the next part, we're going to get rid of the descending order. We won't put them in descending order, and we'll have to reorder them first. And so again, the first thing to do is we see that they're already in that descending order, so let's go ahead and group our terms. And so we'll go ahead and group the first two terms and the last two terms. And then we'll look for those common factors. So we go ahead and look at the 7r to the third and the negative 35r squared. Same thing over here. So here we have a 7r squared. And over here we also have a 7r squared that we can take out. Here we have just a 6. No r's with the 30. So that's as far as we go. Alright, so let's go ahead and do some reducing now. So we've got that 7r squared on the outside of a parenthesis. And we do the reducing. Let's see what's left over. So this 7 will cancel out this 7. These two r's will cancel out 2 of the r's on top, leaving us with 1 r. Well, this 7 will cancel out this 35, leaving us with 5. And all the r's cancel, so it's r minus 5 left over. Let's take a look at the next one here. See, this 6 will cancel out this 6. And let's go ahead and first write down what we have. We've got to take that positive 6 and put it on the outside of a parenthesis. And we can start our reducing here. So I got a little ahead of the game. So again, this 6 will cancel out this 6, leaving us just with the r. And this 6 goes into 35 times. So we have that minus 5. And it should be the same. If it's not, we can't factor out anything. So now let's go ahead and take out that common factor. And so we look at these two terms here. We have the 7r squared times by this binomial, and we have the 6 times by this binomial. And what's in common? Well, it's that binomial of r minus 5. So that's our common factor. And so we go ahead and rewrite our r minus 5. And then over here, we go ahead and see what's left over. See, these r minus 5s will cancel. And what's left over? It's the 7r squared. Over here, these r minus 5s will cancel. What's left over? It's the positive 6. And that's our answer. That's as far as we take it. Well, that's the beginning concept of factoring by grouping. What we'll notice in part 2 is that we're not going to have things in descending order. And also, we might have one that has a common factor between all the terms. So check that out in part 2.